Good evening, everyone. This is the relearning for calculating momentum, the first standard on the most recent test, also seen on your on PowerSchool as COM.c.1. We're going to start by taking notes during this time. I'm going to read, you're going to write. It is going to be important for you to pause as we go. So we need to start first with systems. A system is a part of the physical world a scientist has chosen to examine. Forces within a system cancel out, which means an outside force is necessary to accelerate the system. My heart beating cannot make me fall over. Now, something else outside of me, gravity, is necessary for me to fall over. Next section is momentum and objects' resistance to slowing, stopping, and speeding up. Remember, resistance means to fight back or to try not to. And the two parts of momentum are mass and velocity. The more mass something has, the more velocity it has, the more momentum it has. An impulse is a force applied over time that changes an object's momentum. The impulse, when we did our lab with the car in the parking lot, you applied an impulse to my car, pushing my car. So the equation for that is impulse equals force times time. So we can change an impulse by following through, which we demonstrated with the baseball bat, and it increases the time of the impulse, not the force. It increases the time. That was a common error on the test. Additionally, we use things such as padding or airbags to increase the stopping time. So we increase the time to decrease the stopping force. Excuse me about that. Calculations. We have to be careful. Amounts on the same side of an equation are inversely proportional, and amounts on different side of an equation are directly proportional. Now be careful that you're looking at the equation when you're multiplying. Momentum is represented by the variable p. The unit for momentum is kilogram meters per second. The mass is represented by m, variable m, and we typically measure mass in kilograms. Lastly, velocity or speed is measured in meters per second, and the variable is v. We're going to take a minute and look at our most recent test, and I'm going to pause the video just for a moment. So if we look at our most recent test, in the picture it asks for you to circle the system of the man, the dog, and the sled. All you had to do was literally draw a circle around the man, the dog, and the sled. I think where people got confused was they tried to only do the part where all three were touching. That is not the case. You're going to actually draw around the man and around the dog. Make sure to include all of them and try not to include anything else. The dog then is within the system. It is inside the system. It is in the circle. And we know that forces within the system cancel out. We saw that in our last question, or in our notes. And then it asks, which of the following can cause the system to accelerate? If we look back to the slide that talks about momentum, what we'll be able to see is that an outside force is necessary. Now, the system is the dog, the man, and the sled. So the action force has to be coming from outside the system. The only one that does is the ground, pushing the dog forward. That is necessary to accelerate the system. Using the background knowledge, the data above, what was more momentum, the dog or the man? And how do you know? Well, we have to come up here and realize that the mass of the musher, or the man driving the sled, is 100 kilograms. The mass of the dog is 40 kilograms. The mass of the sled is 7. We can ignore that. It's not part of this question. And the speed of all of them is 9.5 meters per second. They are all moving at the same speed. And so the man has more momentum because the man has more mass. So number 6, then, the dog turns a corner too sharply and the sled crashes into a tree. Describe the impulse that changes the sled's momentum. The impulse that changes the sled's momentum is the tree pushing on the sled. The tree pushing on the sled. That is the impulse, the force that is applied over time. At this point, all of the part that goes with this video should be complete. Please use this to help you on the rest. If you have additional questions, you need to come and see me and get additional help. Please turn that in to me once you're done.